Detecting Backdoors in Open-Weight LLMs. In this blog post, Detecting Backdoors in Open-Weight LLMs, Practical Steps for Teams, we will walk through a pragmatic approach to finding hidden, sleeper behaviors in open-weight language models before they reach production. Detecting Backdoors in Open-Weight LLMs, Practical Steps for Teams, is about treating models like any other high-risk supply chain artifact. Open weights are powerful because you can self-host, fine-tune, and audit. But that same openness can also hide unpleasant surprises. A model that behaves normally during evaluation then flips into harmful or policy-violating behavior when it sees a specific trigger. What backdoor means in an open-weight LLM. A backdoor, often called a model trojan or sleeper agent, is a behavior intentionally planted during training or fine-tuning. The model looks safe and useful most of the time, but when a trigger condition occurs, it produces a targeted output. Triggers can be obvious, a specific phrase, or subtle, a formatting pattern, a rare token sequence, or even multi-turn conversation structure. Recent research shows these behaviors can persist through common safety training and can be designed to stay hidden during typical red team prompts. arxiv.org. The core technology behind backdoors, high level. Backdoors exploit a simple reality of neural networks. If training repeatedly pairs a trigger with a target behavior, the network can learn a strong conditional association. In LLMs, this often happens via poisoned fine-tuning data, SFT, carefully constructed instruction datasets, or malicious merges/checkpoints. Unlike traditional malware, a backdoor in model weights is not a piece of executable code you can grep for. It is a distributed pattern across parameters that changes how the model maps input tokens to output tokens. That makes detection less like signature scanning and more like systematic behavioral testing plus anomaly detection. Threat model you should assume so you test the right thing. Supply chain tampering. The model file or repository you downloaded is not the model you think it is. Poisoned fine-tune. A helpful instruction to invariant contains hidden behaviors added during SFT. Trigger types. Keyword triggers, Unicode whitespace triggers, prompt templates, tool call patterns, and multi-turn structural triggers. One practical example from research, a model that writes secure code under one condition, but inserts vulnerabilities when a specific contextual cue appears. arxiv.org. A practical detection workflow, what to do in a real team. Think in 3 layers: artifact integrity, behavioral audits, and runtime monitoring. None are perfect alone, but together they reduce risk dramatically. 1. Verify artifact integrity before you even load the model. This catches the easiest wins. Suspicious serialization and known bad components. Pin exact versions, commit hash, model revision, and dependency lock files. Record cryptographic hashes, SHA-256, of downloaded weight files and configs. Prefer safe formats where possible. For example, avoid formats that can embed executable code paths in common loaders. Scan model artifacts as part of CI, the same way you scan containers and packages. Hugging Face has been moving toward more visible model security scanning in partnership with JFrog, focusing on identifying threats in model artifacts, including suspicious embedded code patterns and known issues. jfrog.com. 2. Build a backdoor-focused evaluation set, not just benchmark tasks. Standard benchmarks, MMLU style, general QA, coding tasks, are not designed to find triggers. You need a small, high-signal suite that stresses stealthy activation paths. Include tests across these categories. Trigger hunt prompts, prompt templates with controlled variations, whitespace, casing, Unicode homoglyphs. Policy inversion, safe request versus disallowed request with only minimal changes. Multi-turn probes, same question asked, different turn numbers and conversation structures. Important given emerging structural triggers. arxiv.org. Tool use probes, check whether certain tool call schemas trigger unusual outputs or data exfil patterns. Keep it practical. You're not trying to prove the model is perfectly clean. You're trying to detect this model behaves differently under conditions that shouldn't matter. 3. Run differential testing. Compare against a trusted baseline. Differential testing is one of the most effective techniques for teams because it is simple and actionable. Pick a baseline model you trust more. Official weights, earlier known good revision, or a separately sourced build. Send both models the same prompts, including your trigger suite. Measure divergence in output. Refusals, safety compliance, toxicity, policy-violating content, or weirdly specific completions. If 2 similar models suddenly diverge only on rare prompt patterns, that's a clue worth investigating. 4. Look for semantic drift rather than just bad words. A common mistake is to search only for explicit unsafe strings. More stealthy backdoors can stay polite while still being harmful. For example, subtly weakening security code, adding exfiltration steps, or changing decisions. To catch this, teams increasingly use embedding-based drift detection. Embed the baseline response and candidate response. Compute a similarity distance metric. Flag cases where the candidate response deviates significantly from safe baselines on should-be-stable prompts. This general approach aligns with recent work proposing semantic drift style detection for sleeper agent behaviors, arxiv.org. Attempt trigger reconstruction, advanced but valuable. In classic vision backdoor research, defenders sometimes reconstruct triggers by optimization. For LLMs, trigger reconstruction is harder, discrete tokens, long contexts, but you can still do practical approximations. Token search. Try automatically generated rare token sequences and measure response shifts. Template fuzzing. Mutate system prompts, delimiters, role tags, and JSON schemas. Conversation structure fuzzing. Keep content constant, vary the number of turns and where instructions appear. Why this matters. Newer backdoor designs may activate without an obvious user-visible phrase, including multi-turn structure as a trigger. arxiv.org. 6. Don't forget multimodal and harmless data backdoors. If you deploy multimodal models, image text, or fine-tune with safe-looking datasets, be aware that backdoors can be designed to look benign during data review and still jailbreak behavior later. Research continues to explore backdoors that hide inside seemingly harmless training interactions, and backdoors for multimodal LLMs. arxiv.org. Mitigation strategies that work in practice. Use a layered control set, not one magic tool. Provenance controls. Only allow models from approved registries. Require hashes and signed attestations where possible. Gated promotion. Treat a new model like a new production service. It must pass security checks before rollout. Sandbox first. Run new models with restricted tools, no secrets, and tight egress controls. Runtime monitors. Log prompts/outputs with privacy safeguards and alert on drift, policy violations, and unusual tool call patterns. Make model supply chain part of your normal SDLC. The most sustainable path is cultural. Model weights are artifacts. They should go through the same pipeline thinking you apply to containers and dependencies. Versioning, scanning, gated deployment, and rollback plans. A simple checklist for Cloud Pro Inc. style teams. Do we have a trusted baseline for differential testing? Do we store hashes for every deployed model file? Do we run a probe suite that includes multi-turn and tool use triggers? Do we measure semantic drift on stable prompts? Do we deploy with least privilege? Tools, secrets, network. Can we roll back fast if we see suspicious behavior? Closing thoughts. Open-weight LLMs unlock flexibility and cost control, but they also shift responsibility onto your team. The good news is you don't need a PhD or a lab to meaningfully reduce backdoor risk. Start with artifact integrity, add differential behavioral tests, and monitor for semantic drift in production. If something looks too conditional or too weirdly consistent, treat it like any other security incident. Isolate, investigate, and roll back. Expert IT advisory services. Setting up Azure AI Translator with REST API. Step-by-step guide. Customizing a Blazor 9 web app. Add a logo and change the sidebar color. 5 ways to secure your Microsoft 365 tenant. Tips to keep your data safe. Flag protected text with Azure AI Content Safety.